All right, 3, 4 was all about your perpendicular lines, right? The one that applies to number 1 said that the shortest distance between a line and a point not on the line would be the perpendicular segment that connects it. How does that help you with number 1? How does that theorem help you with number 1? Knowing that the shortest distance from a point to a line is a perpendicular segment. What do you know about all the sides of the triangle? Which would be the shortest? DF, right? Because it's a perpendicular segment, right? Everybody understand that? Yeah? So I know from that DF would be less than DE, or 2x minus 3 would be less than 25. So there's an inequality to solve for x. And then I would add the 3 to the other side. 2x would be less than 28, and then divide by 2. Good. X is less than 14. So the question came up, could you put 14 first? Yep, 14 greater than x. That's totally fine too. I could have said 25 is greater than 2x minus 3. And then either way, you're going to solve for the x.
Why would it be an inequality?
Because we don't know anything about the exact lengths there. We just know that this one, because it's got the perpendicular part to it, has to be smaller than that one. So we don't know that they're equal. We don't know that, the DF could equal FE. We have no idea. The only thing that you do know about the two that they give you the lengths for is that the one with the perpendicular, the right angle marked, is going to be shorter than the other one, or less than the other one. All right, number 2 says solve to find x and y in the diagram. So let's look at this diagram. What information is marked on that diagram? They're parallel. Okay, so these two are parallel to each other. What other information? One of them is perpendicular to the transversal, right? What does that tell you? Go ahead.
The other ones.
Good. The other one is also perpendicular, right? If two lines are parallel and one of those two is perpendicular to the transversal, then the other one is perpendicular also. So now I know that those are right angles. So what's that tell you about 8x plus 4y? That one equals 90, and so does, good, 10x. So if I solve the bottom one, 10x is the only one that has one variable in it, right? Solve for that one variable by dividing both sides by 10. X equals 9, good. And then I can actually take that and plug it in here. 8x plus 4y equals 90. Plug that 9 in. 72 plus 4y equals 90. Subtract that 72. Good. So I can reduce this to be 9 halves, 4.5, or 4.5. Again, you can keep it in fraction form as long as it's simplified. So any of those three would get full credit. The 18 over 4, you lose some points because you can reduce that. All right, little practice with proofs. Okay, so again, on the quiz, you're not going to get an open-ended one, so I'll help you with this a little bit. But you do want to be able to justify your reasons, that kind of stuff. So write a 2-column proof given that angle 1 is congruent to angle 2 and P is perpendicular to Q. So the perpendicular part is marked, but the one we can mark that 1 is congruent to 2. And I can use that as my given. So angle 1 congruent to angle 2 and P perpendicular to Q. And my goal is to show that P is perpendicular to R. So my goal is to show that these two are also perpendicular. Does it make sense that they would be perpendicular? Just say I gave you that given information, and without the proof I said, would P be perpendicular to R? How?
Because they're alternate. Oh wait, no. Alternate.
Corresponding, right? So 1 and 2 are corresponding, right? Yeah?
Yeah.
We agree on that? And if they are congruent, what's true about the lines R and Q?
They're parallel.
Good. So if 1 and 2 are congruent, then R is parallel to Q. And if P is perpendicular to Q, and those two lines are parallel, then P also has to be perpendicular to R, okay? Because if one of two parallel lines are perpendicular to the transversal, then the other line is perpendicular as well. So I could go through the long steps of saying that the angle across from 2 or even 2 is 90, and then 1 would be 90, which would make the lines parallel. There's a couple of different ways you could have done this proof, but the shortest way is probably using what we just talked about.
So basically, like, an explanation would be, since one of the coplanar lines is perpendicular to P, then the other one is also.
They have to be coplanar and parallel, but yes.
Oh, and parallel.
Yep. So I can say that Q is parallel to R, and we said the reason there was what?
Because they're parallel.
Why are they parallel? We said it, but we need to actually use the corresponding angles postulate. Most important part is good, converse, because we're saying the lines are parallel. And then I can actually go right to the proof statement. And my reason is if one of two parallel lines is perpendicular to the transversal, then the other line is also perpendicular
One question. If we put corresponding angles in converse, would that be more pro?
You mean because you lost the word postulate?
Yeah.
Actually, let me find out that from Mr. Samariba. So if he takes points off, then I'll take points off, but I'll ask. I know for sure you'll lose if you don't have converse. But the word postulate, I mean, technically just corresponding angles themselves are not helping you with that, the postulate, which says that they are, if they're congruent, then the lines are parallel. But I'll ask him about that. This is the 3-4. So number 1 should have been PR. It said name the shortest segment from the point to the line and then write an inequality for it. PR, and from there you would have gotten X is less than 3.5 or 3.5. Number 2, shortest segment is HJ. I would have said 11 is less than X plus 4, and so X is greater than 7. 3, shortest segment is AB, and X is greater than 9. 4, shortest segment is UT, and X is less than 17. And then 5, the first reason was that M is perpendicular to N. That's the statement. The reason was given. 2, the measure of angle 1 equals 90 degrees, measure of angle 2 equals 90 degrees. That's the definition of perpendicular. 3, this time they gave you the statement. The reason is the definition of congruence or definition of congruent angles. 4, they gave you both sides. And 5, angle 1 and angle 2 are a linear pair. 6 said the Four Corners National Monument is an intersection of the borders of Arizona, Colorado, New Mexico, and Utah. It's called the Four Corners because the intersecting borders are perpendicular. If you were to lie down on the intersection, you could be in the 4 states at the same time, the only place in the United States where this is possible. The figure shows the Colorado-Utah border extending north in a straight line until it intersects with the Wyoming border at the right angle. Explain why the Colorado-Wyoming border must be parallel to the Colorado-New Mexico border. So, I mean, obviously somewhere in your own words, but if they're all straight lines and the one border is the transversal, one of those two parallel lines, but they're both perpendicular to the same line, and if they're both perpendicular to the same line, then they're parallel. We good? Yeah? Okay. So this is, I just added on some extra examples for 3-2. Because what we didn't cover in 3.2 was systems of equations, and you're going to need to know how to do it. So this isn't systems of equations. This is just a quick review. Try to do this example using what you know from 3.2. So this is your corresponding, your alternate interior, your same side interior, all those angles. Okay, solve for x, and then we'll get into one that has the systems of equations. I'll let you work on this. All right, so before I even get to like figuring out the individual angles on the left-hand side, let's look at this diagram. What information does it give you that's going to help you figure out all of those angles?
Lines DF and AG are parallel.
Good. AG and DF are parallel. So, and they give me the measure of one of the angles. Could you find all 8 angles now? Yeah. So let's start with, if this is 70, what other angles are 70? ECF. Good. This one's 70. And why is that?
Corresponding.
Good. Corresponding angles postulate, right? All right. What else is 70?
70 is... Isn't it alternate exterior with AB?
And the one that's missing over there, yep. So this and so these two can also be vertical angles theorem, or these two can be alternate exterior angles theorem. So you could have justified it either way. And there's one more that's 70. DCB, right? This one here. And I could either use alternate interior angles with this one, alternate interior angles theorem, or I could use vertical angles with this one and this one. Okay, so there's a lot of ways to justify it. Which means all of the other 4 angles are what? 110. They would be supplementary to each of these. So 110 is here, 110 is here, 110 is here, and 110 is here. Everybody with me so far? Yeah? Okay, so now if I wanted to solve for x, I've got options. I can either say that 4x plus 22 equals 5x, and then solve that one. I'd get 22 equals x. Or I can say that 5x equals 110, divide both sides by 5, and I get x equals 22. Or I can say 4x plus 22 equals 110, and I'd get 4x equals 88, and x equals 22. So either way you solve it, you should get the same answer for x if you do it correctly. So now that's my value of x, 22. ECF we said was 70 degrees, and DCE is 110 degrees.
What would be your reasoning for A?
So if you went off of what they gave you and you went straight there, it would be the corresponding angles postulate. Everybody good on that example? Any questions? Okay. All right, so now we get here. Again, still only one variable. So you should be able to do this one. Find all those measures. All right, so go through and fill in, right? We know that they're parallel again. So this one is parallel to this one. That means that this is 75. This would also be 75. This would be 75, and this would be 75. Which means all 4 of the other ones are going to be what?
105.
Good, 105. This is 105, this is 105, 105, and 105. Already you know x, right? X is 105. You didn't have to do any work because this one was given to you. And then EDG, which is this angle here, would be 75 degrees. And BDG, which is this angle, BDG, which is this angle here, is 105, sorry.
If you just solve for x minus 30, you just put x minus 30 to 75.
Yep.
And then add 30.
Exactly. So everywhere there's an x, you should still be able to solve for x and get the same value. No matter which way you did it, x should have been 105. Whether you set this one equal to this one, or individually set that equal to 75, that equals 75, it should consistently give you that x equals 105.
Wait, you do want 80 minus 75, right? You don't want to...
Yeah.
Will this problem be on the quiz?
Not exactly like this, but you are going to see ones in which you're, filling in the missing angles, solving for x, that kind of stuff, yeah. Okay, so these next two are the ones that have systems of equations on it. So systems of equations are two equations with two variables, okay? If I look at this diagram and you piece it together, what you should notice is, one, there's three parallel lines that are each parallel to each other, but that the other ones going in the other direction are not parallel. So these are parallel, these are not. So I can't do any relationships from the red line to the red line. Okay, I can't use corresponding angles or alternate interior or anything like that on those. I can on the green lines because those are parallel. So if I go from left to right, what relationships can I set up to solve for the variables? What angle would equal that 5x plus 5y?
55 degrees.
So 55 is on the other transversal. I can't go vertically. I have to go along this transversal. 60. What's the relationship between 5x plus 5y and 60? They're corresponding. So corresponding angles postulate tells me that 5x plus 5y equals 60. Everybody with me so far? Yeah? Okay, what relationship can I set up between this angle and this angle? Ignore that middle line. What's the relationship between those two angles? Almost alternate interior. Good. And what's true about alternate interior angles if the lines are parallel? They're congruent. So I can say that 5x plus 4y equals 55. And that would be alternate interior angle theorem. Are you with me so far? So I've got two variables with two equations. I can't solve that for an individual equation. So I'm going to line them up so that the variables line up. So 5x plus 5y equals 60, and 5x plus 4y equals 55. There's three ways to solve systems of equations. One is by graphing, which you definitely are not going to want to do here. One is substitution, where you would solve one of those equations for one of the variables and then plug it into the second one. The third one, which is the one that's going to be the easiest in a situation like this, is called elimination. So my goal there is to combine these two equations to get one of my variables to cancel out. So if I add these, do either the x's or the y's cancel out? Yeah? Now, without having to change it? No, right? If I add these two together, I'd get 10x plus 9y equals 115.
You multiply one of them by a negative.
Good. So my goal is to get one of them to cancel out. So I'm going to multiply, and it doesn't matter which one. So let's say we want to multiply the top by -1. I'd get negative 5x minus 5y equals a negative 60. Make sure that negative goes all the way to the other side of the equal sign. That's probably the most common mistake people make. Now I'm going to add these two, and the x's cancel. I get negative 1y or negative y equals negative 5. Multiply or divide by -1, and I get y is 5. So my goal is that first step, to get those variables to cancel out. Now that I've got one variable, okay, so now I've got the y, I have to take it and plug it back in, and I can plug it back into either one, but let's say I plug it back into that top one. 5x plus 5 times 5 equals 60. 5x plus 25 equals 60. Subtract the 25. And divide by 5. So now I've got both x and y. So x is 7, y is 5. All right, so if I look at those angles, now the vertical lines are parallel, the slanted ones are not. Okay, relationship between 25x plus y and 120 would be corresponding, so those would be congruent. 25x plus 4y would equal 120. And then 25x plus 5y and 125 are alternate exterior. Those would also be congruent. And then I want to do the same thing with that system. I want to get one of my variables to cancel out. So 25x plus 4y equals 120. I can multiply that second one by a -1, negative 25x minus 5y equals negative 125. And then add them, and if you've done it correctly, one of your variables will cancel when you add, which is that first one. I get negative y equals -5, and 5 equals y, or y equals 5. And then take that and plug it back into either one. So I'm going to plug it back into the first one. 25x plus 4 times 5 equals 120. 25x plus 20 equals 120. Subtract 25x equals 100. Divide by 25, and x equals 4. So x equals 4 and y equals 5.
Well, I thought I was asking for the angles.
Right, so now I've got to actually go in there and find the measures of those angles using the x and the y's. Well, actually, no, you could just do the 120. It'll also ask you to identify x and y. So this measure would have been, the acute is all the other side ones, right? Which would have been what?
Couldn't you have done like 125 minus 180 to go?
For that one, yeah. So for this one,
45.
say it again.
Would it be 45?
Mm-hmm. And then along this line, it would be 60. So all the acute angles down here would be 60. And all these would be 45. And they're different because those blue lines are not parallel, right? So the relationship doesn't carry to the top blue line to the bottom blue line. It's only across on the greens. But if you had a question like this, it would also ask you to solve for x and y. So that's why. Yep.
What if you did like 180 minus 120 from the beginning?
So it would give you the angle measurement, but you'd still have to set up your system to solve for x and y.
What would be the measure of 25?
That one should equal 120. The 25x plus 4y should equal 120. And the 25x plus 5y should equal the 125. All right, so how often do you guys access your book, out of curiosity? Okay, so what you need to do is actually, listen, shh, you have a book, yeah. You need to open up your book because there's an interactive quiz that I want you to take in it to practice for your test.